Hi friends, welcome to the NPTEL course Strategy and Technology, a Practical Primer. We are in week 8 with the theme of Technology and Competitive Strategy. In this lecture, the 38th in this series, we discuss the topic of technological competence. In the previous lecture, we considered competitor analysis and we said that it is best carried out in terms of technological power of a firm. And this form, I said, should be expressed through the fluidic ability and adaptive agility of the new technology. Technology covers, as we know, both product and process aspects and occurs at every point of a product or service value chain. A total technology value chain approach leads to more holistic and more fundamental product redefinition. We need to defocus from established product technologies and refocus on newer and broader technologies that would offer new product and business potentialities. Each part of technology value chain needs to be indexed and multiplied to arrive at the total technological power of the product. In this lecture, therefore, we propose the concept of technology value chain, which is distinct from the firm's value chain. Products or services require a particular commercial format, but technology lends itself to multiple formats and to multiple industries. This represents both a challenge and an opportunity. Technology can create two types of forces. One is a collaborative force and the other is a competitive force. Whether technology is internal or external, it must be viewed as a competitive force or a collaborative force or both based on the context. When you consider technology together with the collaboration and competitive aspects of business, you will get a superior business strategy. It is not necessary for firms to treat technology as a proprietary asset which should not be shared with any other company. Sometimes better benefits accrue by sharing technology with other companies, including competitors. Collaboration in certain aspects of technology improves the competitive positioning of the firm, apart from monetizing the R&D investment that has taken place. How do we analyze technology competence? It is an invisible platform. It is embedded in a product. We need a perceptive ability to identify beforehand in terms of technological feasibility and commercial viability. The new age approach to identify a priori in terms of commercial potential and feasibility is as follows. First of all, we should analyze the kind of products the new platform technologies would deliver. Secondly, we should analyze the technology share ahead of substitute products coming up commercially. Third, quantify the technological competencies of a firm in an industry context. We can do it in two ways. The first way is that a firm analyzes all of its components in terms of the technological power. The displays, the glass, the sensors, the camera modules, the semiconductors, the levers, and so on. The component must be analyzed in terms of the best technology benchmark that is available within that component spectrum. Once you put that, you will know the kind of power you have in respect of each of the components in terms of the technology share, and then quantify the technological competencies of a firm in an industry context. We can also look at it from the component supplier's perspective. If someone is supplying camera modules, the components will be supplied only to a few companies. There would be competitors. So the other way to look at it is that if there are 100 cell phones using camera sensors, which of these are using my products, the competitors' products, and the captive products, and what is the level of benchmark in each of these things. So if my sensors are benchmarked at 90, others are at 95, and the one is at 85, looking at the total production share of those sensors, you can identify your own technological power share that is available in the camera sensors module. This kind of approach, this kind of analysis directly looks at technology as a power. The five forces theory talks about technology, but in a highly indirect way. It considers the substitute product as representative of technological development. While that is so, we need to understand the substitution of products even before that happens. And to be able to do that, we should start understanding technology a priori. The internal technological strength of a product must be understood in detail before we jump to conclusions on the total product power. Let us look at an example from the breakfast cereals industry. And technology includes science and its practical application for quality of life and national progress. When you look at manufacture and distribution of flakes or breakfast cereals, we have to look at the value chain, the technological value chain, from the corn cultivation stage till the consumer stage. We can look at 3 different layers. One is the corn cultivation layer, that includes soil and seed development, the flake manufacture, including testing and packaging. Third, customer delivery, including logistics, distribution and retailing. The highest technological power is derived when each part of the corn value chain deploys leading edge technologies. Very often internal strategists and external analysts miss this point and assess technology only from the end product or consumer point perspective. This leads to quite a high level of lag in holistic appreciation of the total value chain of the technology. Many times technological solutions are developed in parts to meet specific needs. It certainly would be more gainful if each such challenge is leveraged to address the total value chain. Automobile manufacturers of India today, for example, are concerned more about selective electrification of their vehicles than about a complete and holistic redevelopment of their vehicles. The thought process runs like this: incentives are available, we must put an electric vehicle and capture the mindshare of the customer, and the easiest way to do that is to retrofit an electric power pack in the existing automobile. But a different viewpoint would be to completely re-engineer the product with lighter weight materials, with battery distribution all across the chassis, so that there is a better weight distribution and better drive stability for the vehicle. But that requires greater analysis of the manufacturing implications, more investments and delay to the market. It is always a toss-up between which strategy would you do. Even while doing retrofitting strategy, it is quite open for the companies to start developing the native vehicles and come up with a new generation of electric vehicles. Technology must cover both product and process technologies and occur at every level of a product or service value chain, therefore. We should look at parts and the whole. We should not look at only the single aspect. One example comes from the automobile industry. Introduction of non-asbestos gasket in automobiles was a response to regulatory and environmental concerns on the use of asbestos. Companies took up this issue and all the companies achieved replacement of asbestos gaskets by non-asbestos gaskets. Most automobile companies took it up as a gasket-to-gasket fix. Some companies took it up as a gasket-to-gasket fix plus some redesign of the components which are adjacent to the gasket, for example cylinder head and the cylinder block, improve the clearance, improve the finishes, so on. Only a few automobile companies took it up as the total challenge of improving the emissions performance of the automobile engine, the vehicle, and also the fuel economy related to that. Coming back to the previous example, to approach the challenge of healthy foods, breakfast cereal, we need to define the total value chain technologically in terms of agrobiology, aligning crops, and food processing with human physiology and disease pathology. Similarly, when you take up this non-asbestos gasket issue in an automobile, we may have to look at various other aspects which would be causing some kind of deleterious health impact. We could identify these proactively and take it up as part of the developmental process, which will give competitive advantage to the company. So, parts and the whole must be analyzed in a proper and integrated manner. Another example we could take of cost reduction in automobile parts. Obviously, the technological value chain is included, but typically people look at it from a material, component and end product perspective of cost and weight. So the simplest way to look at cost reduction is to reduce the weight of components and therefore reduce overall materials consumption. In fact, Suzuki ran a program of reducing 1 gram in each component and achieved substantial savings in the overall cost of the company. The second way to look at is to enhance the load carrying capacity for a similar form factor of the vehicle. The third way is to bring in new materials in each component so that the strength is improved while reducing the weight and hopefully cost as well. The other way is to look at the frictional loss of engine and hence provide better power to weight ratio. There is a merit in approaching a particular technological problem through a broader technological spectrum. When you are trying to do cost reduction, don't look at only the cost reduction of components or administrative process per se. You look at the entire cost spectrum. But don't stop with cost spectrum alone. Go to the value spectrum. So as you keep doing the cost reduction exercise, you also see value enhancement across the value spectrum. Only then the sum of the parts will be more than the quantitative sum of the parts. The full potential of each part is exploited at each challenge as a part of a total developmental perspective. I talked about defocusing. Let's see what refocus means, what defocus means. Whenever major shifts in strategic perspectives take place, or whenever changes in technological platforms take place, we should address these shifts holistically, substantively, urgently. And we should stop doing things partially and superficially and only hesitantly. The automobile industry will soon redefine itself as a global mobility and navigation industry. That should be understood. That is the refocus. The dairy product industry will redefine itself as a healthy probiotics industry. That also must be understood. An automobile will never cease to be a transportation vehicle just because of the integration of leading edge electronics and global navigation technologies. However, the new automobile will take mobility in higher level, protecting the environment with zero emissions unlike in the past. This is the big difference that is happening in the automobile industry. A dairy product manufacturer cannot cease to be a dairy product company. It will always keep making dairy products. It can also not become a pharmaceutical company because dairy biotechnology has developed to make dairy products that work as gastrointestinal support medicines. But natural medical nutrition will emerge as a new industry vertical. It is not going to replace pharmaceutical industry, but it will promote wellness ahead of sickness coming to take root. The core objectives of products only get reinforced with the convergence of other functionalities. Google will never cease to be an internet company, even if it masters the driverless or autonomous driving car technology. Getting into adjacencies, getting into unrelated activities is supported by the power of the basic business, basic technology. But that doesn't mean that the basic technology itself will move away. The basic technology will continue to get powered by new developments and new improvements. The fact would be that Google will continue to use its core technologies in greater number of new age products, and the core technologies would correspondingly keep on increasing. Technologically proactive firms understand when and how to defocus from the current products and refocus on new products, all the while integrating new underlying technologies. That's why this technology map of a company such as Google or its parent Alphabet, Microsoft, keeps on moving higher and higher, broader and broader. That is the advantage of refocusing versus thinking of defocusing, moving out of one area and getting into another area. No, you should keep on acquiring technologies, strengthen the existing technologies and enhance the technology map of the company. Let's look at this topic of realignment. We can extend and deepen product capabilities by firms based on technological capabilities, but this needs to be distinguished from deliberate moves by companies to shift from one industry to the other industry. Google is making an effort to have electric vehicle, autonomous vehicle. Toyota also is making an effort to get electric vehicles and autonomous vehicles. In this process, Google may utilize Toyota's car, Toyota may utilize Google's technology capabilities. But the fact is that the driverless concept or the autonomous car concept is a technological concept that transcends companies. It integrates companies, but doesn't mean that the core technology of Google vanishes or that the core technology of Toyota happens. What happens as a business understanding or as a business overlay is different from what happens at the technological level. Similarly, a robot, whether developed by Honda as an automobile maker or by Sony as an electronics company remains the same. A robot is a robot. But it is fascinating that companies in two different industries, one in consumer electronics and the other in automobile, are approaching development of robots and converging to developing robots which are much more utilitarian, much more functional, and much more technologically broad spectrum than what the individual industries need. It is important for firms, therefore, to appreciate that technologies can be integrated in a number of ways. There are two important ones though, and each of it will present different profiles, opportunity challenge and risk reward for different firms. Before we do that, let's see how we can do the technology indexing. There is a significant difference between technology cycle and product cycle. The first payoff for technology is in terms of the product that embeds the technology. You have sales, you have profit, you have payback on investment. That's what we understand from technology product relationship in the marketplace. But the industry varies in terms of these characteristics. One industry provides payoffs from the very first investment in technology, whereas in some industries the payback will come only when the full span of the product for 2 to 5 years or 5 to 10 years happens. Clearly, the volume base of new technology products determines in each case when the final payback milestone would occur. Total technological power of a product is more than a sum of the parts, therefore. A technological value chain tends to be only as strong as its weakest link. A high-performance Formula car, for example, cannot drive with only normal on-road tire technology. Therefore, every part of the car must be indexed to higher technological power. Similarly, every product must be indexed to derive higher volumes at the earliest to be able to pay back for the investment. In terms of quantification, a more powerful expression would be a multiplication of the technological indices of the individual parts of the total technology value chain. So, this is the technological competence framework. It is in totality. It objectively indexes each part of technological power and multiplies all the indices to arrive at the total technological power of the product. So it starts with materials technology index, then moves on to the external component technology index, that is components which are taken from the external vendors. Then it indexes the power of the internal component technology. Then looks at the efficiency with which the product is assembled, assembler technology index. And together the total technology index is arrived at. To be able to do that, we should define the value chain. We should refocus by integrating new technologies, index each part of the value chain for technological power, and quantify the total technological power of the product. Such analysis also lets the firm analyze the vulnerabilities, if any, across parts and measure the sensitivity to enhancements. There is no reason why external component technology index should be at 90% and internal 70% or vice versa. And if you have materials technology index at 50%, it jeopardizes all the value chain. So how do we ensure that everything is at the highest possible level of efficiency? That is the transparency we get from analyzing the technological value chain. Many times it is not appropriate or feasible for firms to develop technologies across the total value chain in-house. That's why we talked about the concepts of co-integration, co-development, co-expansion. However, it is necessary for companies to develop a few core technologies organically and access the best of technologies for all the rest, a model adopted by Apple. The core design is Apple's, core technologies are Apple's, and the assembly process is that of Apple's. The supply chain technology is of Apple. The business management processor are Apple's, but many components are made by vendors and even competitors. The core technologies also can be organically developed or collaboratively accessed depending upon the relationship. If we look at this kind of scenario, what are the three dimensions that are relevant to quantify the capability of a firm? The first is the ability to commercially upscale or downscale new technologies across the value chain of an existing product. Ability to upscale or downscale technologies to other products in the same design family. ability to embed the technologies of one product into other significantly different products. Ability in this context requires effectiveness in not only technology but also time and cost. So I have elaborated here the concept of scalability and transferability, which I discussed in the previous lecture. We are saying that scalability within the existing product, scalability within the same design family, and scalability along with, of course, transferability into adjacent products or completely different products. These are the three dimensions relevant to capability of the firm in utilizing the technology. If you get the technologies in strategic partnership with firms, the ability to play on these three dimensions would be significantly higher than trying to do it all by yourself within your own facility, because we get competencies from different angles in different layers and for different components and end products. But this requires the company to continuously scan the intellectual property that is available in the overall industrial spectrum and get into relationships with those companies which have the ability to provide this multidimensional approach for technological competence. And that spectrum or the canvas that will be looked at should include the startups. And once this is done, we should get the best alliances and licensing arrangements so that we have a broader technology competence framework. Let us take, though not related to this topic, an example of Sony Walkman to understand how technology develops and it can capture the imagination of the people, and how a technology that has been so dominant has lost its way because the company did not consider upgrading the technological power of this product. Sony Walkman is an innovation that changed the way people listen to music. Sony's co-founder Masaru Ibuka-san, who wanted to listen to music in his long flights, but found the smallest of audio players then available to be too big to be travel friendly, thought that we should have a small compact music streaming device. A prototype was quickly made by Sony's designer Norio Ohaga-san, and Sony Walkman was then born. The Walkman's prototype was based on a tape recorder that was designed for journalists in 1977. The original Walkman was released in 1979 and it was made of aluminium, while the later editions were made of black plastic casing. Sony's headphones were also a great hit. The device was a revolution which allowed music to be part of people's everyday life. People then used to get to the radios, stationary radios, to listen to music. But with Walkman, people carried the music along with them through the Walkman. It was the first in the long line of portable music players. It was a truly disruptive innovation. It laid the path for iPods and MP3 players. Kuroki Yasuo-san led the development team and became to be known as Mr. Walkman. It is a fact that there was no clearly directed plan to make and sell the Walkman. Young engineers created it just to see if it was possible, and it was never in the product development list for the tape recorder division. This lack of planning is what makes the Walkman story so fascinating. An innovation which changed the way people listen to music came through random creativity of the brilliant engineers that the company had. A portable recording device known as the Pressman, which Sony marketed to reporters, was the basis for the development of the first Walkman. The development period of the Walkman was only 4 months, which was an exceptionally short span for that era, or even this era. Even though the first month's sale was dull, the first 30,000 units sold out in less than 3 months, again a big figure for those times. The Walkman became very popular among the youngsters and made music personal among people. It was not a fundamental discovery in engineering, but it represented a whole new user experience. Probably this is the first time again where user experience came to be known as being more important than the product specification. The uniqueness of the Walkman was the new user experience. Magnetic cassette technology has been around since 1963, but the introduction of the pre-recorded cassette tapes in 1960s opened a whole new market. The Walkman, featuring a headphone jack but no external speaker, made it an ideal product for thousands of consumers looking for a portable compact stereo set they could take with them anywhere and be also unobtrusive. Walkman soon outsold the vinyl records in 1983, and the name Walkman entered the Oxford English Dictionary in 1986. The Walkman became so popular that the number of people who said they walked for exercise increased by 30%. This was a technological innovation that made life better for all. When the Walkman became popular, it was noticed that the listeners used the device to tame the unpredictability of urban spaces with all their unexpected intrusions and loud noises. Wearing headphones functioned both as a personal do not disturb sign and an alternative soundtrack to the cacophony of the city. This was a new form of human experience, engaged disengagement, a technological shield from the world and an antidote to ennui. William Gibson, a pioneer of the science fiction genre, wrote, "The Sony Walkman has done more to change human perception than any virtual reality gadget." Within a few years of its global launch, Walkman emerged as a status symbol and fashion statement in on all by itself. And it was a no-record player. One-san, one of the main developers of Walkman, believed that if one thought too much about a project before doing the project, one could always find faults with it, and too much discussion would create delays. Coming from Japanese consensual method of management, this is a great statement actually. He encouraged his staff to try their ideas before they had time to think about the difficulties that might arise. He put positivity first. And in developing this unique and revolutionary product, he believed that the first model must be reliable. The shape and style of the product could be improved in subsequent models. This aligns with the concept of minimum viable product, which the startups would like to do in current times. So it was thinking decades ahead by Sony. The main job of the development team was to establish the value of this new concept. So the leader decided to use the same mechanism as that of the Pressman. The technologies involved in making the novel product were not new, but assembled in a new way. What the team had to focus on was producing a reliable product, one that delivered value. There was also market research the Japanese way. Many leading Japanese companies like Matsushita and Toyota are skeptical about the Western style of market research, then as well as even now. Japanese always believed in hands-on research. When Sony introduced the Walkman, people were hesitant to buy, as it did not have the record function. But then Walkman made history later. So there were two aspects of market research with reference to Walkman. One was soft data gathering, the other was hard data gathering. In soft data gathering, senior and middle level managers were involved in that process. Frequent visits were made to people and users to help resolve problems soon. Decades ago, therefore, market research was replaced by design thinking without a definition of that sort. In respect of hard data gathering, managers look at inventory, sales, etc. that show the actual numbers. Managers help dealers on promotions and other issues when asked. Tight channel monitoring improved operations and performance. Sony's representatives simply approached pedestrians on streets of Tokyo and gave them a chance to listen to the Walkman. This was one of the main reasons for the product to take off after the initial tepid launch. It was again experience marketing that was put in place decades prior to the concept getting discussed in the Western marketing textbooks. And this was also an innovation that inspired Steve Jobs. Jobs received a Walkman from Morita-san when he was on a business trip to Japan in the early 1980s. When Jobs returned home, he dissected the machinery, reading tiny gears, drive belts to divine how he might someday make something so epic like the Walkman himself. As quoted by John Scully, one-time chairman of Apple, and also Jobs' successor, Jobs did not want to be Microsoft. He did not want to be IBM. He wanted to be Sony. Jobs got his wish fulfilled with the debut of iPod in 2001 in a new, totally different and digital format. So Sony inspired Steve Jobs. The Walkman music had its futuristic functions. Chosen sounds. It gave the listener freedom of choice to listen to their favorite music. It provided learning experience. It helped students to listen to audio recordings for learning purpose. It was aesthetic. The listener's construction of unique perception of their environment, combing their surrounding with Walkman music happened. Environmental control happened. Unpleasant environment sound was replaced by pleasant music. There was interpersonal mediation. Listeners could communicate that they are to themselves and not in touch with the rest of the crowd that happens in a crowded Tokyo commute, for example. And it also activated people to do physical activities such as walking, jogging, dancing while listening to the Walkman music. So there were some futuristic functions that were built into Walkman. Today we may have treadmills with built-in televisions. We may have music systems galore in a gym. But all of these things got embedded in one small cute device called Walkman decades earlier. And that is the brilliance of Sony. But then Sony started declining from its leadership position in respect of the Walkman. Sony still makes exquisite products in consumer electronics, but fewer and fewer people are getting excited about them. In music systems, people think of Bose. In terms of overall breadth of consumer electronics, the Korean giants Samsung and LG have taken a lead position. Why is it that the strategy that once served Sony so well began to fail? One, current product line is crowded and confusing. What is the theme of the product? What does it really specify and amplify for the consumer? What is the experience that is being provided? We had this problem with Sony Ericsson line of cellular phones. We still have with Sony's brand of Bravia phones as also current Xperia. So the message, the thematic message from Sony's products is no longer as impactful as it was with Walkman era. Consumers today care more about the experience, but Sony is still focused on the product. And Sony missed the strategic vision to emphasize the delivery of powerful and resonant user experiences. The goals of the company were mostly hardware focused. Without modifying its business model, Sony has been left behind by a world that has changed its relationship with technology from usage to experience. That's the summary we get from Sony's decline from its leadership position. So we have seen how a product, through random creativity and through the power of the people who are supporting it, become blockbuster product. We also have seen how without acclimatization to the new emerging environment, the product may lose its appeal. In fact, Walkman created the concept of user experience, but more and more products that should have come into this ambit of user experience were never developed. Therefore, the lineup itself overall got relegated to second position or third position. This brings us to the topic of the symbiosis that could exist between technology and strategy. Technology and strategy influence business in 4 ways. We can develop this strategy based on technology and build our business. First is proprietary technologies. We establish pioneering and uncontested products. We build our core businesses, companies and industries based on proprietary technologies. The page search technology of Google helped the company build its proprietary search engine business. Nobody could challenge that. Similarly, click technology of Amazon helped it build the e-commerce platform. And several companies similarly have their unique proprietary technologies. Second, platform technologies. These can be accessed by different stakeholders creatively. They help redefine multiple businesses, companies and industries. We can have the third type, which are the business innovations. We create radically new business strategies and business models based on the technologies and help reinforce companies and transform industries. In spite of having proprietary technologies, in spite of having platform technologies and business innovations available for leaders and managers, we have seen failures. Companies, despite having unique technologies, do fail. That could be due to misapplication, mistiming, or such other factor. We have seen the case of Xerox developing graphics interface, mouse, and even building its own computer prototypes, but failing to be a behemoth in the computer business. Similarly, Eastman Kodak. Its engineers pioneered digital photography, but the industry was taken over by somebody else. The following slides provide some examples relating to each of the above, demonstrating the importance of technology. There are proprietary technologies which built core businesses, companies and industries. If you have core proprietary technology, it's quite possible that you will build the industry yourself and stay perched at the top. AE exploration, Standard Oil, made petroleum and petroleum products indispensable to the world. AT&T made telephonic and telegraphy transparent and transportable, and it created a monopoly of telecommunications revolution. McCormick Harvesting Machine Company, it did the harvesting machine and it revolutionized farm productivity. Ford Motor Company in 1908 did automobile design and manufacturing in a very novel way at that time, moving assembly line based on standard production, and it made automobiles affordable to masses. General Electric founded on electricity and light bulbs and lighted up the entire world. This is one set of examples. We have another set of examples. DuPont specialized in material technologies: Teflon, Rayon, Dacron, Lucite, Freon, Lycra, Orlon, Neoprene, Mylar, Kevlar, Cellophane. You name the latest material technology, DuPont was the first to enter in that field. Google Web Internet digitization connected the world, eased up living like never before. RCA, NBC, they pioneered audio and video broadcasting. Apple brought in smartphones, tablets and desktops, transformed the whole world of mobile connectivity. Bayer brought in sulfur drugs. They were the first antibiotics of the world, treated infections, and opened up a completely new era in disease-ridden world of those times. And these companies are founded on pioneering scientific and technological innovations. A few more examples of more recent times. Tesla pioneered electric self-driving automobiles as the total future of the automobile industry. That is the competitive effect. And the technology was electric self-driving cars. Amazon revolutionized print publishing and the entire e-commerce business. Digital sales and marketing was the technology used. Adobe brought in the concept of portable document technology. Standalone company, it made portable document format only on PDF. It has become a world leader. Sony brought in portable music. We discussed this case with quite some detail. Walkman portable radio music device. It revolutionized how music can be portable and personalized. Otis, it brought in elevator technology, helped vertical construction of buildings, ushered in skyscraper architecture. Without Otis and the elevator technology, skyscrapers would not have come about. As Adobe demonstrates, it's not the scale and scope, but intense identification with a phenomenon is all that matters. Some more examples. Facebook came in with the social networking as the technology and built digital social communication. Wright Company brought in airplane and the aircraft built airline business. Thyssen Group pioneered the steel making technology, and steel making became a business and industry. Michel Energy came up with fracking solutions. Shale gas and oil became the new oil business. It led to game-changing boom in US oil and gas production. Microsoft came up with the concept of operating system for personal computers, and it revolutionized personal and desktop computing. Information technology started a new wave of computing, while digital started a new wave of social connectivity. Platform technologies, in addition, redefined multiple businesses, companies, and industries. The third and fourth industrial revolutions are marked by product technologies using platform technologies. The entire corporate world today uses the VPN connection technology, and it has led to lower travel work, freedom to work, smaller offices, and smarter offices. All device companies use Wi-Fi today, and Wi-Fi revolutionized enterprise and personal communication. All web developers and enterprise users use LAMP stack, Linux, Apache, SQL, and PHP. It has created cheaper open source development. Therapeutics, that is CRISPR Therapeutics, and all other drug discovery companies through drug licensing route use CRISPR-Cas9. This has led to unlimited gene editing opportunities, personalize the medicines. All automotive companies use advanced automation technologies today, and this has provided machine-learned automated perfection. Healthcare uses biomics, a combination of biology and genomics. and it has restored sensory feedback in neuroprosthetics as an example. Web as a place to have everything, a world of its own. World Wide Web changed the world forever in terms of connectivity and information storage, information processing and information communication. Fintech and banking companies started looking at blockchain. Cryptocurrencies and distributed ledgers began appearing, and cryptocurrencies are challenging conventional currency. The fourth industrial revolution will fuse digital, mechanical and biological into one integrated technological whole. There is no doubt about it. Business innovations transformed industries through new companies. Uber came up as a new company based on digital ride handling technology, and it transformed transport and cab industry. Netflix, it started offering online on-demand video streaming through digital technology, and it transformed movie watching globally. Airbnb, global home rental platform, transformed business and leisure travel. WeWork started giving co-working spaces, transformed office utilization, especially for SMEs. Salesforce.com, cloud computing and customer relationship management, it revolutionized marketing effectiveness of companies. Digital technologies, each customized to the respective business model, to the business process, ensured that new businesses were created based on these digital technologies. The technology in each case could be different, but the core is the digital approach to technological development of business process. This trend will continue to develop with additional personalization and perfection through artificial intelligence. In spite of having unique technologies, some companies fail. Therefore, technological innovation need not necessarily be correlated positively with sustained business success. Despite having core proprietary technologies, many companies fail because of the failure to set the right competitive strategy. In the business or in the technology of smartwatch technology, Pebble was a pioneer. But because of the falling prices, failure to track health activity, failure to market right, this technology and the company failed. Google itself came up with Google Glass. It's a smart wearable product. High price, privacy concerns kind of destroyed the product. Alta Vista came up with the digital answering technology, but poor management led to its failure. GM EV1 was a company of electric car development. Lack of scale and focus saw to it that company folded up. Palm Pilot PDA, the first palm-held computing devices, communication devices between the person and the device. It was a digital product diary. Failure of management led to the failure of the product. AOL was a great internet service provider. Uncompetitive technology and high pricing made sure that the company failed. BlackBerry was a leader in QWERTY keyboard smartphones. It offered internet-based smart telephones. Inability to forecast touchscreen technology, inability to forecast that others also would be offering encrypted security, saw to it that BlackBerry never progressed beyond its cocoon. Had BlackBerry looked at these trends and updated its technology, had it co-developed this technology, co-integrated, co-expanded, probably BlackBerry of today would have been far more distinctive than it is today. Napster, unfiltered exchange of songs, what is its technology model? But ignorance of intellectual property and copyrights ensured that the business didn't take off. Clearly, technology and strategy need to work in tandem, together, with alignment, with synergy, with harmony, so that the full impact of technology is commercially realized. We have seen many examples of technology leading to industry domination, industry creation and then industry domination. We have seen platform technologies transforming many industries across the board. We have also seen business models coming up due to new technologies. Now we have seen technologies being available were not utilized properly, and therefore the companies that pioneered the technologies failed. There are very good lessons from these kinds of discussions that we have gone through in this lecture. These are the keynotes related to these case studies. Thank you very much for your attention. We will meet again in the next lecture.